Mini lesson 3F, rational word problems. Linear divided by linear. Rachel is examining the cost of adding fruit punch to the menu at her bake sale. The equipment she needs to make the fruit punch costs $85. She also calculates the cost of cups, straws, and ingredients to be $1.25 per cup. If Rachel plans to make X cups of fruit punch and sell all of them, write a function C to represent the mean cost per cup of fruit punch in dollars. We're going to say there's X cups, and it's $1.25 per cup. That would be 125 X. The cost of the equipment she needs to make this fruit punch is $85. So we're going to add $85 to this linear expression. We're finding the mean cost per cup, so we're going to divide this by the total number of cups, X. We have a linear divided by another linear. That's going to give us our cost function. C of X equals 1.25X plus 85 all over X. Mixtures. 18 pounds of fruit salad was made by combining 6 pounds of sliced peaches, which cost $5 a pound, with 12 pounds of dragon fruit, which costs $8 a pound. Find the cost per pound of the mixture. We will have two equations. One that is the total weight, and one is the cost of the mixture. The total weight is 6 pounds of peaches plus 12 pounds of dragon fruit. It gives you 18 total pounds. We have that equation already. Everything is filled in. The total cost per pound would be 6 pounds of peaches, and they're $5 per pound, plus 12 pounds of dragon fruit, and it's $8 a pound. That's going to equal 18 total pounds of fruit salad times some amount of that mixture. And put C. From here, we can solve for C. 6 times 5 is 30. 12 times 8 is 96, equals 18C. 126 equals 18C. Divide each side by 18. 7 equals C. This means that the mixture of fruit salad costs $7 per pound. Work problems. Samuel can oil the lanes in a bowling alley in 6 hours. Sammy can oil the same lanes in 8 hours. If they work together, how long would it take them? Our general formula for this would be 1 over the first person's rate times the time it takes, plus that same amount of time over the second person's rate equals 1 job. Samuel's rate is 6 hours, so we're going to say R1 is 6. And Sammy's rate is 8 hours, so R2 is equal to 8. Let's plug these into the equation and solve for T. 6t plus 8t divided by 48 equals 1. Multiply each side by 48, and then we have 6t plus 8t, which is 14t, equals 48. Divide each side by 14. You can simplify this fraction by dividing each of them by 2. 24 over 7. T equals 24 over 7. That gives you about 3.43. This means that it would take Samuel and Sammy about 3.43 hours to oil the lanes if they work together. Working alone, Eduardo could pick 60 bushels of apples in 9 hours. One day, his friend Nusha helped him, and it only took 5 hours. How long would it take Nusha to do it alone? We have our equation. Together, it would be 5 hours. That's T. R1 would be Eduardo's rate, which is 9 hours. We're going to solve for Nusha's rate. Let's plug these into the equation and solve for R2. 5 over 9 plus 5 over R2 equals 1. Let's subtract 5/9 from each side. We have 5 over R2 equals 9 minus 5 over 9. From here we could cross multiply. 9 minus 5 is 4. Then we have 45 equals 4R2. Divide each side by 4. R2 equals 45 over 4. Let's approximate this. 11.25 hours. This means it'll take Nusha about 11 hours and 15 minutes to complete this alone. Direct variation. The distance required to stop a car varies directly as the square of its speed. If 330 feet are required to stop a car traveling at 70 miles per hour, how many feet are required to stop a car traveling at 20 miles per hour? Round to the nearest whole number. The general formula for this would be y equals k x to the r power. In this case, r is going to equal 2 because the square. Says 330 feet, that's going to be the old y. And the car's traveling at 70 miles an hour. That's going to be the old X. And it wants to know how many feet, so that's the new Y, are required to stop a car traveling at 20 miles an hour. That's going to be the new X. Let's set this up. 330 equals K, which we're solving for, times 70 to the second power. 70 to the second power is equal to 4,900. To solve for K, we're going to divide each side by 4,900. We just said that K equals 33 over 490. We'll leave it in fraction form for now. That's the constant of proportionality. We're going to plug that in with the new X to get the new Y. Y equals 33 over 490 times 20 squared. Evaluate this. 20 squared is equal to 400. So we're going to go back to this and multiply this answer by 400. We get about 27. This means that 27 feet are required to stop a car traveling at 20 miles an hour. Inverse variation. The general formula for this one is y equals k over x to the r power. When renting a limo for prom, the number of people varies inversely with the cost per person. Originally, there were 5 people and the cost per person was $50. If the number of people changed to 10, what would be the new cost per person? We have our old X and our old Y. Now we have the new X, and then we're going to solve for the new Y. We have 50 equals K divided by 5. Multiply each side by 5 to get the K by itself. 250 equals K. Let's plug that in to find our new Y. Y equals 250 over 10. That will give you 25. This means if there were 10 people, it would cost $25 per person. To rent the limo. Parts of a whole. In a garden, 1/4 of the crops are turnips. 1/2 are carrots, and 2/3 of the remaining crops are beets. The rest of the crops are potatoes. If there are 144 crops in the garden, how many potatoes are there? Let's draw a little rectangle to represent our garden. It says 1/4 of the crops are turnips. 1/4 of the whole thing is turnips. Half of them are carrots. So half of this whole thing right here is carrots. And then 2/3 of the remaining crops are beets. So this amount is beets. And then the rest of them are potatoes. That'd be this amount. Let's figure out how many pieces we would have if we put 3 into each of these other 3 rectangles. Let's draw it out again. So we have half and we have fourths, and then for the 2/3 of the remaining, we're going to have 3 in each of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 pieces altogether. And if one of those pieces is potatoes, you have 144 divided by the 12 pieces. That gives you 12. There are 12 potatoes. A way to show this algebraically, we could say that we have one whole garden minus 1/4 of the crops being turnips minus half of the crops being carrots. And we're going to multiply that by the potatoes. To get that, it's going to be 1 minus the remaining 2/3. And then you'll multiply that whole thing by 144. 144 times 1/3 times 1 minus 1/4 is 3/4, and 3/4 minus 1/2 is 1/4. Multiply these, you get 144 over 12 again. And that gives you 12.